Local programming on KRWG Public Media made possible in part by viewers like you. Thank you.
This is KRWG Public Media, TV, radio, online. News that matters. Now, across the Mesilla Valley and the borderland, the stories that shape our community. From the KRWG Broadcast Center at New Mexico State University, this is Newsmakers.
Thank you for joining us for Newsmakers. I'm Casey Counts. Scientific evidence continues to show that human activities, primarily the burning of fossil fuels, have continued to warm the Earth's surface and its oceans and continue to have an impact on the planet's climate. That's according to NASA.gov. New Mexico State Climatologist Dr. David Dubois joins us to discuss the growing challenges faced by our planet and how we're being affected in southern New Mexico and around the region. Dr. Dubois, welcome to KRWG Public Media.
Thank you.
Why don't you start just by telling us and describing for us what the role of the state climatologist is?
Yeah, well, the state climatologist is basically coordinates climate programs, education, coordination, and basically brings in climate to help, make our state prosperous, and because we need to know extremes, averages, for tourism, for agriculture, for water management, and so I get to take part in lots of different programs to kind of help them use climate in their kind of the everyday, usage. Mm-hmm. Yeah, and so I've been doing this for 13 years now, and every state has a state climatologist now, and I'm one of them, and we kind of work with lots of different entities, and we're statewide.
Do you work with the state climatologists from other states as well and communicate well together?
Yeah, absolutely. I have good friends all over the country, specifically with drought. Drought's kind of our big topic right now. So I coordinate with Colorado, Texas, and Arizona most frequently, usually twice a week, to talk about drought and where it's getting worse or it's getting better. If we get some rain, maybe we can ease drought, but it's sort of that. It's a nice fellowship of people that we get to know. Well,
I know we're going to talk a lot more about that topic, drought, in the course of this program. But I want to move on now, because you mentioned education, and obviously science is so important in terms of educating not only industry-specific individuals, but the public at large, and politicians who need to be able to make appropriate decisions for their constituents moving forward. Let's talk a little bit about the role of climate science in politics. How political is your job?
Yeah, well, it can get pretty political. One of the things I wanted to focus in on, since I work at NMSU as a professor and faculty here, is kind of work with students, as well as is work with the professionals are out there who may not know all the facts, or they may not know sources of data. So I've been really focusing on climate literacy. This is a specific topic to talk about, so where do we get the information, and so how do we interpret things like climate change going into the future for 40, 50 years. So how do you interpret those things, and all as well as seasonal outlooks, because those are kind of confusing. Talk about probabilities, because a lot of folks don't really know kind of the concept of probabilities and kind of looking forward. So I try to translate some of those into simpler terms and kind of talk through them. So it's kind of bringing things to a more common words, the words that you usually use with like my family members, and because that's one of the things that you practice with my family members, to kind of say, how do I say that? And so students, even elementary school students, we need to start early with them talking about climate change, and all the way up to our seniors, people who are, they have a lot of influence. And so I have lots of programs with them, as well as like master gardeners and different workshops with different state agencies. So education is a real big part of what state climatologists do.
Sounds like you stay pretty busy.
I am very busy.
You mentioned the word, complexity, and kind of removing those complexities so that we can all understand the language that we're using when we talk about climate science. But is that complexity of the science itself one of the challenges that you find in terms of political will?
Yeah, Well, I mean, my first challenge is to understand it myself, and a lot of times I like, boy, how does this work? So I may call and talk to somebody, who's, who's really either authored the paper or kind of knows more than I do. We learn from each other, and say, oh yeah, that's how it works. Let me see if if I can explain it to them back. And that's kind of how I address a lot of education. Is like I give them a concept and say, can you, in your words, can you repeat what I just said? I'm not like saying you have to do this, but it's more of kind of getting the sense of, okay, so what does this mean to you? And does this change any of your viewpoints in the past? Does this change anything, how you, work out problems or talk to other people? And, that's, and especially with political figures, that's really important. And a lot of folks are on board, but some of them, they may agree on that climate is changing, but the disagreement is on how we address it and who's causing it. And so and I've been working on that for a long time, and we don't always agree on things, but that's fine. It's more of getting talking about it and discussing that in a good way.
Science is obviously extremely valuable in politics, and while people disagree about there are still people, obviously, who disagree that humans are causing change to our climate. But I want to talk a little bit about scientific consensus. And it seems like for a long time now, there has been a scientific consensus that climate change is happening and that human beings are causing some percentage of it. What can you tell us about that?
Yeah, so we don't pretend to know everything, of course. As climate scientists, we work on the best available information, and we don't usually do it on our own. We do it through help from others, like that example of I learned something new. I need to make sure I understand it. And we do that not only just personally, just talking like we are now, but through the publications. So I may draft a journal article, with multiple co-authors, and it goes through a peer review process. And they may find something that say, oh, you maybe reword that or something, So there's a lot of check and balances in terms of making sure that the science is correct, and basically we have references, bibliography that backs up the information that we're saying. It's not just pulling it out of the thin air and just kind of blanket saying it, but we have to make sure it jives with the scientific, the consensus of all the publications that have been published over time. And so we don't always agree, and that's fine. That's part of how things work out. We have disagreements on little stuff and then occasionally some big stuff.
Yeah, indeed. Well, let's take a look now at a chart showing some temperature data showing rapid warming in the past few decades. The latest data going up to 2022. According to NASA, 2016 and 2020 are tied for the warmest year since 1880, continuing a long-term trend of rising global temperatures. On top of that, the 9 most recent years have been the hottest. And this is from NASA's Goddard Institute for Space Studies. But if you'll notice on that chart, we are looking at 4 different sources there, actually, which are tracking along the way pretty similarly. We're also seeing the Hadley Center for Climate Research and the National Oceanic and Atmospheric Administration Center for Environmental Information, as well as Berkeley Earth. So does that give us just a bit of a really simple look at kind of what consensus looks like along the way and what's happening, especially since about the late 70s?
Yeah, absolutely. A lot of those groups you mentioned, they come at it looking at similar data sets, but they may use different areas. I mean, it's the globe, so you have to look at the cryosphere, which is the frozen part, the poles, as well as the equator, the oceans. And there's not a lot of data in the oceans, right? We have a lot of weather measurements in the continental areas. We got weather stations, we got airports and things like that. But when you deal with oceans, it's very difficult to come up with measurements. And you use satellite data, and you kind of blend them together, you put it all together, and then you come up with an average. And in each of those agencies, groups, they come up with little different methodologies, and each of them thinks their way is the best. And so it's sort of like not quite a competition, but they say, oh yeah, I think this is the best way of doing it, and I'll do it, and I'll publish it this way. And each of those do it the same. They come up with the same, pretty close to the same answer. I mean, there's a little variability because the data sets are different, come out with just a little bit different methodologies, but that's the consensus is you look at the bigger picture, not the individual little teeny details of, oh yeah, that one was a little bit less than the other one, but you let the zoom out at the whole picture. It's like, what is that graph showing as a whole? Over time, are they all going in the same trend? And are their variabilities pretty much the same? Those are the big things to look for in interpreting graphs. Not the little 1 year was a little bit different than the other, or a 2-year trend or something like that. Those are kind of methodology changes and the way things are they put together, but the bigger overall trend over time. That's what you look for.
Do people ask you everywhere you go if it's hot enough for you, especially this last summer?
I prefer warm. That's why I live in Las Cruces. But no, there's a limit to when the heat index gets really high. We're blessed to live in more of a semi-arid area as opposed to somewhere in the southeast, which is much higher dew point temperatures, which means a higher relative humidity.
So we should say it's a semi-arid heat.
Yeah, that's right.
Record-breaking July. Obviously there maybe are a couple of factors that went into that. Very interesting about how El Nino can affect our summer heat and our monsoon season.
Yeah, we broke many records this year. I'm still tabulating all the different numbers and everything, but July was the hottest July on record for many places, all over the place. And actually, we have had the hottest for Las Cruces. We have a weather station on the NMSU campus since like 1892. It was the hottest July and the hottest summer on record. And it was interesting, though, to note that we also had the hottest low, the warm, the coldest day. The warm temperatures the morning temperatures have been climbing up. So that's another one we've been tracking. Not just the high temperatures, but the low temperatures have been also creeping up.
And so what is affecting that, traditional nighttime cooling?
Yeah, so we expect in the nighttime, in the mornings, to have a nice cool. We go for walks, open up the windows, and we should feel nice and cool. That's still there. However, the temperatures have been climbing up. That we had an 80-degree morning, and so that's pretty high. I mean, there were other places around in the Southwest that's more common, but not in Las Cruces. So there's some problems with that. Is if you don't have air conditioning or cooling, that's going to be a problem for a lot of people.
I spoke with someone from the National Weather Service recently about this year's El Nino and the monsoon season, and some interesting information they shared with me about going back and looking at El Nino years and how that impacted our monsoon season, pushing the rains back, but that there was hope that we would still make up for it maybe in August and September, and now it's looking like that is a little bit iffy. So tell us what you think we can expect for the fall.
Yeah, so a lot of the past summers that have been transitioning into El Ninos have been kind of very dry. Not all of them, of course, but there's some that have been dry. And then, so the El Nino, which is part of the El Nino Southern Oscillation, it's a Pacific phenomena that actually affects our jet stream. And so what that has an impact on us, it's in the wintertime. So, which means that we could get some more, the storm tracks are more where we are in New Mexico as opposed to further up in latitudes in Colorado. So which means the probability of more storms in the wintertime. So it's mainly a wintertime phenomena for El Nino. And so the latest forecasts and outlooks I was looking at were showing that the wintertime is likely going to be, in terms of probabilities, if you were to place bets on it, it's most likely going to be a wetter and cooler wintertime compared to average. And so we had a really wet and cool one this last winter, which was opposite to what we were expecting.
During a triple La Nina.
Yeah,
right?
exactly. Yeah. I mean, we got it right on 2 of them because we had 3 of them. We were warm and dry on 2 of them, and the last one it kind of was very weird. Atmospheric phenomena. It just kind of didn't follow a lot of the traditional rules, and it was very hard to forecast.
Do you expect to have more of that in the future? More confusion and difficulty forecasting?
It could end up being that way. I think with the averages moving up in terms of this, not only the land surface but sea surface temperatures, we get a lot of our influence on the oceans. Like for instance, the El Nino is actually, we get influence way upstream in the East Asian jet stream over in another continent. And that reflects on how our storm tracks go. So, anytime when we get changes in that, our predictability, we basically can't always rely on the past to predict the future. And so that's why we have these numerical models, the supercomputers who basically they put in the dynamics of the atmosphere, the whole sphere, to kind of bring it forward and model what's going on. And this last year, we saw that, the really dry monsoon, and I personally say, I'm not sure about that. I don't know if I'm going to actually want to say that to people, that it's really going to be a dry monsoon. And so, from my experience, it's like, okay, I see the models, but I don't know if I trust them. I should have trusted it because that's what happened. It actually panned out. The models were trending in that direction of a really dry monsoon. So, so there are some learning for our own selves. Yeah. In sort of using the tools that we have, and we don't always have the right answer, but a lot of us do, and we just have to kind of.
I think that's one of the things that really paints a picture for us in terms of how complex science and politics and their relationship can be. Yeah. So no doubt, it's some difficult decision making that's ahead of us. Are you able to say how much our burning of fossil fuels contributes to our changing climate?
Well, absolutely. I mean, that part is our consensus. If you look at some of the documents and publications that have gone on over the last several decades, they all point to us as contributing to that. We have a nice blanket over the Earth called the greenhouse effect, and that's natural. But we're slowly tweaking the concentrations of those molecules that actually make it nice and comfy for us. As we do that, we see that. So it's a cause and effect. It's not a correlation. It does correlate, but it's a cause and effect, and it's well documented. It's been out there for more than 100 years about that. That's what's causing the major trend. There's weather patterns that cool even warmer, but there's that long-term trend over 100 years. That's what is causing it.
How do you characterize the future of fossil fuels at this point?
Well, I mean, we rely on those. That's how we heat our houses. I mean, that's how we run our TV studios like we're in right now. We drive our cars. We're relying on it, and it's served us well. However, knowing what we know now, we got to think of the future, our kids, and we got to do it intelligently. To transition from something that's cleaner, so that we don't keep doing what we've been doing and keep causing that problem. I mean, it's sort of, I look at the numbers and say, yeah, we got another hot year, and it's like, well, we've got to do some changes, but it's that, how do we do it? That's when it becomes political, is who says it, and back and forth, but I think looking at the past, we got to learn from the past on how to transition things.
So let's talk a little bit about those renewable energy resources. The SunZia project just broke ground in New Mexico. Yeah. It'll obviously be some time yet before we see the benefits of that, or other states see the benefits of that. What does New Mexico expect to get back for something like that?
Yeah, I read the news too on the SunZia. It was like 3 gigawatts of energy, and I think that's great. I mean, it's I've driven through the areas by Corona, and there's lots of wind turbines out there, and I think that's kind of that's the trend. Both solar and wind are kind of our resources here, and so I think that's where we need to go. I think, and is to invest more in those, and to make it more of so that New Mexico can use it. We don't. I mean, it's always hard to see when a lot of it goes out of state, but we got to make money, and we can do our own thing here too, I think.
Mm-hmm. Overall, do you believe that dry places will be drier, hotter, and cool, wet places will be colder and wetter? Is that the trend we're
on? We throw around the word aridification. So we're already semi-arid, so it's always dry, right? It's pretty dry, especially in the spring. The outlooks and a lot of the what climate change models are showing, is maybe the springs get drier, and that's the way it changes the way we think about our how dry it is here, and it's all the way up to the mountains, where we get our water for agriculture. That's that hotter, more evaporation. It's tougher for plants. It's a slow increase. So it's not like it's boom, it's here. But from our lifetime, it's a slow process, and then that's what we call more aridification is sort of the new term that we've been talking about. And so how does that look like? How does that pan out? What do we need to do about it in terms of adapting to that term and looking at, so what about how do we manage more productivity with less water, for instance? Those are big questions. I don't have answers for them, but we're tossing about answers and discussions right now, and so that's what's going on right now.
How much do you think we're going to see migration increase due to climate change, even within the United States?
Yeah, I think it's possible. I think especially some of the big urban areas, even potentially even some agricultural areas. I know in the Ogallala Aquifer, east part of the state, in the West Texas and north of there, their water keeps getting deeper and deeper. They have to drill, and less water, and it's like they can't make ends meet using the water that they used to get. So that's sort of either you transition to something else or you move out, and so that's kind of what we're seeing. I don't know how urban. It's a tough job for urban water managers. Is where do we get the water, and do we reuse the water?
I did read about a pipeline that they're installing in eastern New Mexico to bring water in.
Right. So, but it's investments. Those are very expensive to bring water, to pump water, even just a few 100 feet up. It's a lot of energy, and who's going to pay for? And then there's, the right-of-ways. Paying for. It's very complex, and it turns political.
We've seen the complexity in other pipelines, right?
Absolutely.
But if this one spills, it's just water.
Right.
Well, I want to talk with our last few minutes here about, you mentioned adaptation. Mm-hmm. So let's talk a little bit about, what we can still mitigate, but what we have to plan to adapt for.
Yeah. So there's tons of publications out there right now, and there's a national climate assessment. We even have a 50-year water plan that's being drafted by the Interstate Stream Commission, State Engineer's Office, and so they're talking about adaptation. So how do we deal with less water and hotter droughts? And a lot of it's going back to some of the days when we didn't have as much technology. Like the 50s. The 50s were drier, but our droughts now are hotter than the 50s droughts. And so it's a little different, but we can learn from the past. So what did they do? Or even the 30s Dust Bowl, and so there's adaptation is many forms, and it all depends on which sector. We kind of look at what are the possible futures, and so how do we modify what we're doing to match that future, whether it's tourism, agriculture, transportation, protecting the environment, land management. They all have different ways of adapting to these, but you have to have some kind of a plan, and you have to. Most everybody has to kind of go along with it, and milestones, and figuring out, so how do we actually do this, and what it's going to cost money a lot of times, and some of it doesn't, but some of it's going to have to, in terms of, figuring out, what if, health is a big one too. Like Department of Health is a big lift in terms of how do we deal with these extreme heat. We talk in terms of more viruses and new viruses. There's all those other things that go along with the heat, and it's with hospitals having to deal with more ER visits, emergency room visits for heat-related illnesses, and then cooling centers and things like that. That's a big issue. And then how do we deal with the urban heat island in cities now. We've created these areas where it's artificially hotter than the outside of the town, and you know, by more than 5 degrees in some cases, maybe even up to nearly 10 degrees in some places. And so how do we manage that, not to make it worse than what we're even having for a heat, you know, at the you know, like in the desert, it's cooler, but if you go in town, it's warm, you know. So
concrete, right?
The concrete, yeah, it stores heat, you know, and it's hot all night even.
Can we see whether solar farms create their own little heat islands at this point?
Well, I don't know. I think there's a lot of talk about, you know, managing, you know, having grazing with wind turbines and solar. There's also a lot of discussion about when you put solar, the photovoltaic is having agriculture underneath. And there's a lot of talk on it. It's like, but that could work because you're shading and you're providing shelter for the plants, less evapotranspiration loss, less water use. So you know, let's look at those things.
Obviously, still lots of discussion and still lots of science and work to do along the way. One message with the last few seconds here that you would share with politicians that you have the ear of in terms of what is the most important thing to do.
Well, I think is look for trusted sources of information. I think that's probably one of the big things. Is you know, I work a lot with NOAA. That's our organization that deals with climate, and they are the parent organization for the National Weather Service. You know, for heat warnings, go directly to the source for them. And for, you know, anything weather-related, floods, all the way to heat, you know, those are the trusted sources. That's just one example of it, you know.
Well, thank you so much, Dr. David Dubois, state climatologist, for sharing your insight with us on this extremely important topic. We're so glad to have you.
Glad to be here.
And that's our time for now. Join us this week on KRWG Radio. Every weekday, it's Morning Edition from 5 a.m. to 9 with Fresh Air at 11, followed by Here and Now from noon to 2, and All Things Considered from 4 to 7 p.m. KRWG News is always online at krwg.org, and we'd like to hear from you. Email us with story ideas and video submissions. The address is feedback@nmsu.edu. For all of us at KRWG News, I'm Casey Counts. Have a great week, and we'll see you next time on Newsmakers.